This is the EC504 final project presentation. We are Group 3 and we're doing the file deduplicator project. We have 4 team members, Hansen Zhang, Yutun Pan, Chunxi Yang, and John Ying. My name is Hansen Zhang and I'm going to walk you through our presentation. So this is an outline of our 10-minute presentation. We're going to talk about relevant background, algorithm, encoding, decoding of the files, the graphical user interface, the command line interface, as well as the testing. And these are some of the relevant background that we use for our project. We have the ramping hash algorithm, and we have the dynamic chunking algorithm. These are algorithms that we used at the early stage of our project development, and but we later on we just discarded those. This is the most important background of our project. It's the Google Stiff Match Patch library. It is a library based on Miles' paper. It implemented a robust algorithm to compare and match 2 files of plain text. Alright, so this is the algorithm of our project. So basically, it makes use of 2 sliding windows within 2 strings to look for character and mismatches. And when a mismatch is found, the windows are then later used for another more detailed match algorithm to find the exact type of changes that were made and the content of those changes. Those information are then stored into a vector of changed objects, which will later be used for file retrieval. Here's an example of how the algorithm works. If we were given 2 strings, the first one is A, B, C, D, E, F, the second one is A, B, C, D, E, F. It's going to regard those 2 strings as one A is inserted after the first A in the first string. So if we run the algorithm on those 2 strings, we're going to get the outcome like this. So we're going to have one change object. The content field of this object is going to be the character A. The position is going to be 1, which is the position where this A is inserted, and the type is going to be an insert, which means that this is an insertion.
Hello, this is Yutun Pan. I'm gonna walk you through our encoding and decoding part. For the encoding part, we mainly have 3 subparts. First of all, it's read files or folders. Second, save single files. Last but not least, save single folder. For read files or folder, first of all, for reading files, we read files by byte because we want to avoid missing any information about line breakers. That's why we avoid using read by line. And we save it in the saved object where we save the file content and the file names both as strings. For reading folders, we simply read the files inside the folder one by one. We just call the read file by bytes for every single file in the folder. For save single files, we generate the database folder under the root folder, and we take the first one as the sample file and save it. By saying sample files, we mean that for each file that comes after this one, we'll read this one from the database, compare it with the input file, then we generate this difference. We find the difference and we serialize the difference to the database. For save the single folder, it's pretty much the same strategy as saving one single file. If the folder is saved when the database is empty, the first file in the folder will be treated as the sample file. Otherwise, compare all files in the folder with the existing sample file and save differences to database. Also, we will generate the folder in the database instead of just saving all the files to it, which makes our database more organized. There's 2 things you guys should know about our encoding part. First of all, we have a name.txt file to track all the file names in the database. It helps the front-end GUI, especially the GUI, to have a combo box that includes all the file names. Also, we prevent the user from saving the file with the same name twice or even more, because we want to prevent overwriting the sample file. Otherwise, the sample file will be empty. For the decoding part, it's pretty straightforward. First of all, we deserialize the differences files in the folder. Then we read the sample file from the database and combine it with the differences files. Also, and after that, we generate the original file and retrieve it from the database. We'll save it in a retrieve folder under the root folder. All the retrieved files will be saved in there.
My name is Chengxi, and I'm going to talk a little bit about the GUI part of our project. Our GUI is designed to include all the basic features of our deduplicator and to make it more user-friendly. We use the Java Swing widget toolkit to build our GUI and incorporate all the backend functions through the API. To specify the input file or folder of our deduplicator from the GUI, we use the JFileChooser widget to open a dialog for users to select a file from a specific directory nice and easy. We added a text field to open a dialog for users to select a file to display the file name of a selected file so that users can confirm with it before they proceed. Once users have finished selecting, they can simply click on the Save button, which performs an action to call our wrapped up file storage functions and start storing the file into our database. As soon as all the work is completed, we let the GUI pop up a dialog window to indicate that the file has been successfully stored into the locker. In the meantime, we update the progress bar down below so that the users can have a basic idea how much storage of the locker they've used. This is done only after a file is stored, since we don't have the delete feature, and this is the only time when the locker storage changes. We also have a combo box with a list of files currently in storage, which is also updated after a file is stored. When users want to retrieve a file from the locker, they can simply select a file from the list and click on the Retrieve button. This action will call the file retrieve process from the backend and then put the retrieve file under the root directory.
In addition to the GUI, we have a command line interface where we have the duplicator Java file, Java archive file as the executable. Then we have an option, the first option being file with file path value, the second option being locker and locker path value. Using both options in one command line will allow the user to store the file at that file path at the locker at the specified path. We also have a GUI option which simply by itself opens the graphical user interface by itself. We have unit testing here where we test various modules of the deduplicator. The first one being string comparison, where we use sample string with various character edit patterns such as add, delete, and replace character. That we test the string comparison functionality on these samples and verify the content of the resulting data structure will contain the file changes. For file operation for source and retrieval file, we have sample files that differ by at most 5 character edits and folders to contain them. That we use the sample as input and verify creation of file change data in database. And then likewise, we retrieve the sample files and verify the content of the retrieved files in the output folder. Testing the command line interface, we simply input the arbitrary file and locker paths as argument and have the program return these same values on the command line. For the graphical user interface, we input arbitrary file path and have it being output on the command line. Also, we have a command line output different button press messages for each different button on the GUI. System testing, our approach is that we use 10 megabyte ASCII files as input, each different by at most 5 characters, which are manually edited by one of us. We use sample folders to contain some of the aforementioned sample files. Then we perform file store operation for each sample file and verify creation of change data in the database. Then we do the file retrieve operation on each sample file and folder, and we verify the content of each retrieve file through the unit diff command. In system testing, we use both interfaces, the command line and the GUI. For command line, we store files using the command line, while we retrieve files with the GUI because the retrieve file functionality is not implemented on the command line. For GUI, we use both file operations through the GUI. And that is all, folks.